Hello my dear students, this is Akash HD. Welcome to the AHD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the question from the chapter Semiconductors came in a exam CBSE 2024. Important for NEET and JEE both because this is based upon the doping of the semiconductor. Very basic question. Okay, so let's go through it. The question is, a pure silicon crystal having 5 into 10 to the power 8 atoms per meter cube is doped with 1 ppm concentration of antimony. Okay, now see, if the concentration of holes in the doped crystal is found to be, this data is given 4.5 into 10 power 9 per meter cube, the concentration of intrinsic charge carriers in silicon crystal is about how much? Okay, so here this silicon crystal, actually the semiconductor in its purest form is called the intrinsic semiconductor. So here this silicon crystal is the intrinsic. Okay, after that it is doped with this antimony. So based upon the doping, the semiconductor can become n-type or p-type semiconductor. This is called extrinsic semiconductor. That means when we are doping a intrinsic semiconductor, it becomes a extrinsic semiconductor. So here it is given antimony. So remember that here phosphorus, arsenic, antimony. Okay, these are the pentavalent impurity. They will make intrinsic semiconductor after doping n-type semiconductor. Similarly, if I talk about the boron, aluminum, gallium, this will make a intrinsic semiconductor after doping p-type semiconductor. Okay, and remember that whether n-type semiconductor access electrons, p-type semiconductor access holes, but they will be electrically neutral. Okay, so see here. So here we can see antimony is there, that is the pentavalent impurity. That means which kind of semiconductor we will get? A extrinsic semiconductor n-type. Okay, so see here now. So silicon crystal, how many atoms are given here? See here please. 5 into 10 to the power 8 atoms of a silicon crystal is there, and they are doped by how much here? 1 ppm. ppm means parts per million. That means 1 part per million. So see here please, I have written here the very basics here. 1 ppm doping means what? Here we can say here number of antimony atom in 10 to the power 6 atom of silicon crystal. How much? 1. That is called 1 ppm. Kindly see very well. Is it? So this is called what? 1 ppm. After that, how many atoms of silicon crystal is there? 5 into 10 power 28. Here we will apply the unity rule here. Okay, so see here again, 10 to the power 6 atoms corresponds to 1. Is it? Now after that, let's see here. Now I have written all the language things so that we can see very well. Next one, see the number of silicon, this antimony atom in a 5 into 10 to the power 8 atom of silicon crystal. So you know very well 10 to the power 6 stands for 1. Then 5 into 10 to the power 28 will be how much here? Kindly say very well, unity rule. 1 by 10 to the power 20, 1 by 10 to the power 6 into, it will become here, see, 5 into 10 to the power 28. So when you will simplify this, it will come here 5 into 10 to the power 22. So see here, number of antimony atoms in 5 into 10 to the power 28 atoms of silicon crystal is how much coming here? This is coming this one here. Okay, atoms, more than 1 atoms. Is it? Now see here, since 1 pentavalent atom donates 1 free electron to silicon crystal, so the number density of excess electrons in silicon crystal is how much here? Is it? Because silicon crystal is doped by the antimony atom, and how many atoms came? 5 into 10 power 22. Each and every atom will provide 1 electron access. Okay, so in this situation, the number density of the electron in the silicon crystal will become how much here? Whatever atoms, each and every atom 1 electron, so it will become here number of electrons 5 into 10 power 22 per meter cube. This is called here the number density. This is the number of electrons here. Now we know that number density of holes in silicon crystal. Holes, how much is given here? Kindly see here. Already it is there. The number of holes is given here. See here. 4.5 into 10 power 9. These holes are given here. So I will write here. This number of holes is given here. 4.5 into 10 power 9 per meter cube. Is it? So number of holes is this one, and the excess number of electrons, how much is there? This one. After that, we'll use the mass action law. According to the mass action law, we know very well here, Ni square is equal to Ne into Nh. Is it? Ni is the intrinsic carrier charge density that we have to calculate. Okay. So see here, please here, Ne how much is there? See here, 5 into 10 power 22 into Nh how much is given? See here, 4.5 into 10 power 9. Simplify this, is it? So this will become here, Ni square is equal to 5 into 4.5, it will become here something 22.5 into 10 to the power 22 plus 9, it will become what? 31. Is it? After that, again if we will simplify this, it will become here 2.25 into 10 to the power 32. Is it? Now we can write here the intrinsic charge carrier is square root of 2.25 into 10 to the power 32. So square root of 2.25, how much here? It will come here 1.5. And square root of 10 power 32, it will become 10 to the power 16. And that will be per meter cube. Can you see very well? Is it? Very well. Is it? So students, here we have learned that when a silicon crystal is doped with the antimony, it has become n-type semiconductor. In n-type semiconductor, holes also there, free electrons also there. But which one majority carriers? Electron is the majority carriers and holes are the minority carriers. But still, after doping also, this silicon crystal, that means n-type semiconductor, is electrically neutral. Remember that. Okay students, keep studying, keep growing.